Okay, so 26 says to approximate the length of a marsh, a surveyor walks 425 meters from point A to point B. The surveyor then turns 65 degrees and walks 300 meters to point C. Approximate the length AC of the marsh. So if you look at the picture that's there, here's your 425, right? So he starts here, he walks 425 this way, then he turns 65 degrees, which is where that angle is, and then he walks 300 meters. So the 65 is on the outside of my triangle. How do I get the angle on the inside of the triangle? Subtract it from 180 because those two are a linear pair or form a line. That means that this is 115 degrees. So if I want to know AC, which is here, I can say that X over the sine of 115 would equal, this is law of cosines, not law of sines. Go away. This is side angle side, right? So that's law of cosines. One of your challenges is going to be that, right? Figure out what information you've got. This, I know I have two sides in the included angle, which means you've got side angle side. And for that one, we're going to do law of cosines. So it would be x squared equals the other two sides, so 300 squared plus 425 squared minus 2 times 300 times 425 times the cosine of 115. And then don't forget to square root whatever you get from that, and that's going to give you that 615.1 meters.
I think I got it wrong because I was trying to do law of sines.
Yeah, just be careful. Those word problems are going to get blended in together. So you've got to kind of look at what you're given. Side angle side and side side side. You're going to do law of cosines, right? Of cosines. And then if it's angle angle side or side side angle, you're going to do law of sines. Mm-hmm. Any other questions from that first page? So 6.1, 6.2, start of 6.3. Or that there's a difference between a unit vector, right? This says unit vector in the direction, okay? That's when you just do the component form over the magnitude, split it. If it then said find a vector with a magnitude of 5, let's say, in the same direction, as, let's just pull 46 down here, negative 12, negative 5, what's the difference between that and the unit vector one? At the end, you're going to start it the same way. You're going to still do component form over the magnitude. But at the end, with the one that gives you a magnitude, you're going to multiply that 5. So I would have done the work to get to here. And then I would do 5 times negative 12 over 13, negative 5 over 13. So if it gives you a magnitude, so you get negative 60 over 13 and negative 25 over 13. So those are two. They both say same direction, but one is a unit vector, which means you don't multiply anything by the end, and that magnitude should be 1 at the end if you check it. And the other one, it's going to give you a magnitude, so you're going to multiply that in. Everybody's good? Mm-hmm. All right, then we went to dot product. All those properties of dot products. We went to angle in between, like number 70. Make sure you can graph them. Make sure you'd be able to find the sum using the graph, all that stuff that we went over yesterday. So to find the unit vector on this one, we do the component form, so negative 12 over negative 5 over the magnitude of that, which would be the square root of negative 12 squared plus negative 5 squared. So that's 144 plus 25, which is 169, and the square root of 169 is 13. So then I'd get negative 12 over 13 and negative 5 over 13. If the bottom had a square root, I would rationalize. This time I got lucky and it didn't, so you just have to simplify it. But that's unit vector. So unit vector, you don't multiply anything in at the end. Same direction with a different magnitude like the one that I wrote in there. That's when you're going to multiply the magnitude in at the end. Any other questions? Okay, and then yesterday we went over a word problem. Remember, I said it's not on this, but the word problem with the horizontal change and the vertical component and the horizontal component.
So if you want to find the factor of 9 to the 5, you just multiply both numbers by 5.
Yep.
Okay.
Yep. Everybody's good? And then orthogonal, parallel, and then your complex numbers. Yep.
I don't get 78. Like,
78.
How do you know?
So remember that there's 3 ways, right? One thing I could do is find the dot product of these two. I could do 8 times 5 plus -4 plus 10, 40 plus a -40. And if the dot product's 0, it is. Or I could find their slopes, right? So if I did the slopes, it'd be -4 over 8 and 10 over 5. And that's -1/2, and that's +2. If they're opposite reciprocals, it's also perpendicular, right? I would say if you found the angle between already, look at it. If it's 90, you know. But you're probably not going to find the angle between. I would choose one of those first. Yeah.
So it have to be 0 for
The dot product has to be 0, or the slopes have to be opposite reciprocals. For it to be parallel, you just look at the slopes. The slopes would have to be the same. You wouldn't look at the dot product.
Can you go over 46?
40s. I said it yesterday, but I can't stress it enough that you need to make sure you're paying attention to the directions. If it says to round an answer, you're going to round it using your calculator. If it does not, you're going to keep it exact. So like these numbers down here are going to be exact. Anything with a square root is going to be kept exact. The things that I want you to round on, we'll say to round. Everybody's good? Yeah? Okay, so this is your side angle. I know this because if I draw this out, A, B, C, remember if I get one of each letter, I'm okay. But if I don't, I have 30 degrees. I have side B, which is 27, and I have side C, which is 32. That's 2 sides and the non-included angle. This is a 7. So this is a case that could be 1 triangles, no triangles, or 2 triangles. So I'm going to start by first finding the first angle that I can find. I have an entire ratio in B, so I will always use that. I'll always use 27 over the sine of 30. And then the other information I have is side C. So I'm going to say C, which is 32, over the sine of angle. And we're going to call it C1 because we're going to assume that there could be a second triangle. So then I would do 32 times the sine of 30. Divide that by 27, and then I'm going to inverse sine that number. So 32 sine of 27, and then I hit that wrong. Sorry, 32 sine of 30. Divide it by 27, and I get 0.5925. If that number was 1 or bigger than 1, would be a no triangle scenario. Okay. So then I'm going to hit inverse sine. I'm going to pull that number back in, and I would get angle C1 is 36.34 degrees. So then I'm going to assume there's a second triangle, and I'm going to start with that angle. C2 would be 180 minus that 36.34. That's how I find that second triangle, which is 145.66. So angle C2, 145.66. So I'm going to finish out triangle 1, and then I'll go back to triangle 2. I have side A, I have side C and angle C. I have side B and angle B. I'm missing that third angle, which would be angle A1. And I would do 180 minus 36.34 minus the original angle that was given, 30. And I get A1 is 113.66. And then the last thing I have to find is side A1. I'm still going to use my original information because I know that that's right. 27 over the sine of 30 would equal side A1 over the sine of 113.66. Cross multiply 27 times the sine of 1, 13.66, divided by the sine of 30. And I get A1 equals 49.46. So from my first triangle, I've got side A1, angle A1, and angle C1. Now I'm going to continue with my second triangle. So I got to find A2, angle A2, by doing 180 minus the original angle that they give you, because that's still part of both triangles, minus the 145.66. So 180 minus 30 minus 145.66. And angle A2 is 4.34. If that was negative, then I rule out my second triangle, right? If it's positive like it is, I know there's a second triangle, which means I have one more step, and that is to find side A2. I'm still using the initial ratio that they gave me. Good morning. 27 over the sine of 30 would equal A2 over the sine of 4.34. 27 sine of 4.34 divided by the sine of 30, and I get A2 is 4.09. And then from the second triangle, you've got A2, side A2, angle A2, and angle, C2. Remember, this only happens in a side-side angle scenario. If you have angle, side, if you're given two angles on one side, there's no possibility of a second triangle. You just complete it, right? You find your third angle using 180 minus the other two, and then set up your ratio.
You know how I remember it?
How?
Like, you know how it could be SSA?
Or
It could be
yeah.
backwards?
If you spell a bad word forwards or backwards.
I remember bad that. I remember that this is a bad problem. That's how I remember that.
It's a pain in the
Exactly.
SSA reversed.
Exactly.
Yeah. Mm-hmm. All right. Everybody good on law of sines? Yeah. And then we did a side angle side with law of cosines. Everybody good on the area for this one? Just don't forget that it's sine, not cosine, right? If it's side angle side, it's sine. So that should have been 0.5 times 7 times 8 times the sine of 52. And this would have been the area here, 22.06. I think it says to round the area to like nearest tenth, but just pay attention to the directions. Then came the law of cosines. So remember, law of cosines, the parentheses are important, and you want to start with the largest angle. So law of cosines, you're either going to give in side angle side, which was like the word problem from the homework, or you'll give in side, side, which is like this example. So for these, I'd start with C. So I would do C squared equals 12 squared plus 17 squared minus 20 squared over 2 times 12 times 17. And then again, I'm going to do cosine. Sorry, this is not C squared. This is cosine of C. And then I'm going to do cosine -1 of that whole thing, making sure I put parentheses around the numerator and the denominator. 12 squared plus 17 squared minus 20 squared divided by 2 times 12 times 17. And I get angle C is 85.36. Now, because I did the largest one first, I can actually switch to law of sines. But to do that, I'm going to have to use this rounded number. So you are safer with sticking with law of cosines. So then the next one I could find is angle B. So cosine of B would be A squared plus C squared minus B squared over 2AC, which would be 12 squared plus 20 squared minus 17 squared over 2 times 12 times 20. And then again, I'm going to do cosine -1 of that entire thing. 12 squared plus 20 squared minus 17 squared divided by 2 times 12 times 20. And I'd get angle B is 57.91. And then to get angle A, I can subtract the other two from 180. Or I can do law of cosines and make sure I'm right. Just don't waste too much time on something like that if you know you're going to be short on time. Paolo.
Would you use the rounded values or the long values when you get your calculation?
If you're doing the 180 minus them, you can do the rounded ones. If you're doing the law of cosines, it's going to be more exact. You don't have to round it because you're going to use the original values, which aren't rounded.
Excuse me, can you go up a little bit to